Hello. So I'm in Belize watching a sunset right now. Outside I can see the sun setting, and I opened up Stellarium and I'm looking at how this is mapped out, and I see the sun at about 7 degrees now, and it was about 8 or 10 degrees moments before when I was looking with my phone using my phone's gyroscope. Now, as you see, we're just watching it move on the firmament. I have the North Celestial Pole is here, and you can see how it is marked out 20 degrees from the celestial pole, the North Celestial Pole. That would then mean, and the moon's a little closer up. So now if you see on the left right here, and now I'm now plotting the locations of the sun and the moon on the firmament. As you see here in like the official software, the moon is closer up than the sun. These are the right ascension and declination. This is how astronomers map stuff. And if you look in really closely, you can actually even see it moving. It's quite funny. So you can see on the right how you can see the firmament moving, and that is what we see happening in real life. Whether it is the firmament moving or the sun and the moon and the stars moving on their own paths, that's hard to say for sure. But that is what's happening when we see the sun setting. It is moving to a different location on the firmament, and this is measured. Let me move my face down here so I can be out of the way. If you see in the top the location of the sun and moon, and any astronomy software is measured with the right ascension and declination, and this is how heliocentrists would track the location on the dome firmament. Now, to understand what I'm saying about location, for example, the North Star Polaris, that would be right here at this dot. Let me pull that up, and you can see it's right there. Now, let's move locations. Let's go to Argentina. We want to pass the equator. Now, you'll notice that the North Celestial Pole is beneath us, and you can see that we can't see anything at all, actually. That'd be within 10 degrees of the top of the firmament. So this is where it gets interesting, and where you got to understand how vision works in our universe. So let me face the South Pole. At the South Pole, there's a star. I believe it's called Hadar that I was tracking. That is this dot on the firmament, this blue, I don't know if I can move it around. See right here. Let me also move me back up. Oh, don't move that. That was my face. I like to show myself just so people know that I'm actually like a real person, and these aren't just troll videos. But yeah, so at the bottom of the firmament is the South Celestial Pole. Does that make sense to you? So this star Hadar is physically located at that location on the firmament, and we're seeing it projected onto our South Celestial Sphere. Now, this is how vision works. Remember, the physical world isn't actually real. Consciousness is more real than the physical world. So that's something that you do need to understand, otherwise the idea of a celestial sphere might not even make sense to you. But the important thing to understand is that those objects are not physically there. You can't actually go there. And that's one of the reasons why they had to fake the moon landings. You cannot go to the moon because they're actually on the firmament. And this solves another problem that many people have. Are the sun and the moon in the firmament, or are they physical objects moving around? And the answer is they have to be on the firmament, and that's how we can then align our cosmological model to the heliocentric cosmological model. And they both work. That's what I was trying to explain at the start of this video. If you go out here, if you live in Argentina and you look up in the sky and you see this blue dot and you test your gyroscope, it'll be at 50 degrees from your horizon, and at your compass it'll be 135 degree tilt. This works. You can't deny this cosmological system. You instead have to understand how it works, and the geocentric cosmological model, specifically with the firmament implementation. So we know that the bottom of the firmament, the farthest bottom point, is that point right there, the south celestial sphere. So that's important to understand. It's not a real place that you can go to, and that's why no matter where you are in the south, if you're facing south, you're going to have a south celestial pole rendered. The south celestial pole is a dipole magnet. It has a north and a south, 2 points, whereas the magnetic field has unlimited south poles. On flat Earth, it's a toroidal magnetic field, and there is no south physical pole. So that can confuse a lot of people, because you can go any direction south, face that way, and you will all see the same celestial pole depending on your latitude. So that's another important thing as well to notice. See how right here I'm at about negative 35 latitude south? That means the south pole is also going to be at about 35 degrees from my horizon. So you see in the top right of my screen, 35 degrees from the horizon. This is true wherever you go. So let's go back to Belize City, where my latitude should be about 17 degrees. See right there, 17 degrees north. So that means my north celestial pole is also going to be about 17 degrees from the horizon. This is how the globe model was reverse engineered from the real life flat Earth model. And due to the way our universe and consciousness and just being alive as humans works, it's hard because both models can be reverse engineered from each other, and there's no real way to know unless me and you can go to space. We're not going to know it's flat. We just have to trust the authority figures and the narrative they want us to believe for the time being. So that is important to understand. So let's go back to this equatorial grid, it's called. You can use this in any sky mapping software. Just open up an equatorial grid, and let's find an object, if we can, along the equator. I don't know if that's possible right now, but let's actually... So yeah, this is my sunset. The sun moves around the dome. As it moves around, it disappears. That's really all it is. We're looking at a projection. This is a celestial sphere. But let's change the time. Okay, awesome. Now, can I get it right on the equator? Okay, cool. I think I have it right on the equator. That's pretty cool. So what that means, though, is that for this particular time, where the sun would physically be on the dome firmament is halfway. So it would be at the halfway point, right there. And where's the moon? The moon is a little bit closer than half. So the moon would be on this side, since it's closer to the North Pole. And that is how we can look at objects with what's called the equatorial grid and know where they would be on the firmament. Let's go back to the sun. See how, let me turn off the azimuthal so you really understand this. See that grid there? That is literally the firmament. It's a projection of the firmament. And you have to understand that. That's why the sun is not changing sizes as it moves away or is setting. It's not actually setting, if that makes sense. Let me zoom up a little bit more on a sunset so you understand what's happening. Can I move the hours? Yeah, so see that path it's taking? Let me move my head out of the way. So as we go through the hours, it's going to follow that path along. It's not choosing its path. It's going around the firmament. See that? And then underneath. Now, it's not changing size. It didn't actually go anywhere. It's the firmament moving or the sun moving on the dome firmament. So that is why it'll disappear without changing any size. Let me see if I can play that back in slow motion. See how the dome's rotating. That's all it is. And then throughout the seasons, it moves closer and away from the North Pole. So let's go to winter. See how now it's getting closer to the South Pole? This is our winter. Right now, this is December. So then for this time of the year, the sun will follow this path right there. And then as it gets in our summertime, you could say, the sun moves closer to the North Pole. So see that path it's traveling right there? And that's all it is. And it's rotating on the dome. That's what I really want you to understand, how the sunset and sunrises work and where the locations of the objects are. So let's go actually back to December, where it was here now. See how it is on the bottom half of the equator, you could say. So now what that means is if we go back here, we know the sun is physically down there. And the moon, we can see, is right there. So the moon is actually even farther down right there. So this is how everything works. Vision works, south and north pole works, how sunsets work as well. This answers and solves many questions.